Hi, everyone. My name's Kaylee, and I'm a systems architect down in Charlotte, North Carolina. Moving forward, I'm going to be joining a new company as a data scientist. I'm super excited to get to put to use some of the knowledge I've gained here at Northwestern while completing my master's program. For my capstone thesis project, I wanted to go ahead and use reinforcement learning on financial data sets. My side hobby has long been automated trading, and I'm always looking for a way to improve my process. Without further ado, let's dive in. Financial machine learning applications are both highly valued for their use and notoriously finicky to optimize to a point where they're actually usable. While many studies have discussed financial reinforcement learning structures and hyperparameter optimization, here I wanted to delve into how some simple modifications to the observation, reward, and environment can significantly impact profitability. By providing volume, RSI, and price feed data in the reinforcement learning observation, profitability was improved by 40%. To generate the needed data for this study, a custom script was used to pull down foreign exchange trading data from the Oanda Web Trading API. I trained and tested the data on a selection of Euro USD data from January 2017 through May 2021. While data could be downloaded in increments as small as 1 minute, I wanted to have a good balance between a large quantity of data points and the stability that comes with trading on larger timescales. In the end, I selected the 1 hour timescale for this reason. For this study, the Euro USD currency pair was selected because it's a relatively stable pair without the dramatic fluctuations that can be seen in some other currency pairs, such as JPY. In the end, this resulted in over 27,000 data points. It should be noted weekend data was not included in the study due to a lack of weekend trading. Just to give you guys an idea of what this actually looks like, you can see here on this chart is the Euro USD currency pair from 2017 all the way up until today. So as you can see, there's a good amount of both up and down movement. And this is what I was largely looking for when selecting a currency pair. I wanted to make sure that there was both a lot of opportunities to go long, go short, and places where the model should really consider just holding and doing nothing. So yeah, this is what it actually looks like. This is in the 1 day increment opposed to the 1 hour increment. The 1 hour increment would just be a lot more data to fit on the screen at one time. If any of you have ever been involved in trading before, you will likely recognize some of the things on the screen. Here, there are both green and red bars indicating price action moving up and down over time. This is the main indicator for the price action occurring within our trades. Here, this line indicates volume. Volume indicates the amount of activity and liquidity currently occurring within this currency pair within the set time frame. On this line, there's something called relative strength index. RSI is basically a 14-step moving average of both up and down price movements over that time period. When the RSI value reaches over 70%, it's typically considered overbought and price action is likely to fall. When the RSI value is below 30%, it's considered oversold and price action is likely to increase. In this study, I wanted to primarily explore the impact of including price action, volume, RSI, and a combination of the three as part of the observation in an automated trading model. In this process, I would use deep Q learning, a type of reinforcement learning that uses a neural network to calculate which action to take, as well as a custom environment. A simple environment is designed for this study. At each time step, the model has the option to enter a trade, wait to see what will happen next, or exit the current trade. Non-valid actions, such as trying to exit a trade when a trade is never started, results in the action being changed to wait. If a sell action results in profit, the model is rewarded +1. If, on the other hand, a loss is recorded, the model is penalized -1. By structuring the reward this way, the model is encouraged to avoid losses and sell immediately when a trade is profitable. This is not necessarily efficient trading, but it is the easiest reward structure for the model to learn. A reward structure that provides a positive reward based on percent gain/loss from the starting price to the selling price is also discussed in this study. The previously discussed environment is effectively the game our model is attempting to master. It accomplishes this task through trial and error, at least in the beginning. The model randomly selects actions and observes the rewards and feedback it receives from the environment. This has been previously described as the observation, including the current position value, price history, and the optional volume and RSI values. From there, the observation and reward are stored in memory. As memories accumulate, the model becomes more intelligent in its decision-making process by utilizing memories that resulted in the highest rewards in the decision-making process. This decision-making process is handled by a deep neural network, which compares the current observation to the stored memories to select an action that will optimize the reward. This deep neural network is made up of 3 layers with 100 hidden nodes each. As training progresses, the model gradually makes random decisions more seldomly, progressively making more informed actions. The training process is designed to start off by making random decisions 100% of the time and to slowly decrease randomness to only 10% by the 300th episode, a reduction taking place at each time step. By the end of training, the model has been through more than 6 million time steps and has formulated a solid decision-making process based on the provided input. As mentioned before, the 4 primary models generated were a model that included price action, another with price action and volume, and a third with price action and RSI, and a fourth that combined all 3, including price action, volume, and RSI. Here, you can see the results. All 4 models produce consistent profits, with the volume model being the most profitable and the RSI model being the least profitable. The combination model produced the highest mean and median profits. In the initial comparison of the 4 base models, I hypothesized that adding additional price indicators, such as volume and RSI, would benefit the model's ability to identify profitable trades. This has been proven correct in the case of the volume and combination models, but it's more ambiguous in the case of the RSI model, which produces the worst results. I generally believe this is more a matter of the hyperparameters being optimized for the base model. Given better tuning, I think all non-base models may outperform the base. I believe this to be the case because of the strong performance results of the combination model, displaying the highest mean and median profits by a healthy margin. The next area of investigation had been the reward structure. Rewarding the model with plus versus minus 1 based on positive versus negative profits encouraged the model to avoid losses, but also encouraged it to immediately sell as soon as profits had been gained. The reason a different reward structure had not been initially chosen is because there were significant hurdles involved in getting the model to learn using a profit-based reward structure, such as the one mentioned here. In this version, I continued to provide a -1 reward for losses, but provided a positive reward based on percent price gain from entering a position to selling it, with 100%, being the maximum reward. The only model that showed real promise here is the combination model. This model produced the highest profit seen across all models, as well as the highest mean and median profit values. This indicates that this is the best model for further exploration and optimization. One of the benefits to trading on a foreign exchange market is that it's designed to take advantage of both short and long positions. This means money can be made regardless of the direction of price action. Up until now, we have only explored models that trade in the long direction. But in this next set of models, the environment is modified to optionally allow either trading either way. This theoretically gives the model more valid trading opportunities. The challenge faced with this model is that in every case, the model picks only one trading direction, short or long, and learns to only trade in that direction. While I believe it's still possible to teach a model to trade in both directions, I think it might require a learning structure other than deep Q learning, such as a multi-agent learning environment. At the very minimum, a different array of hyperparameters is needed. Given the results of this study, it can be concluded that a deep Q network is a viable method of market trading that can produce profitable results. The more data provided in the observation, the more intelligent the model is in making trading decisions. From this study, the most successful combination of parameters included a combination of price action history, volume values, and RSI values provided in the reinforcement learning observation, as well as a profit-based reward structure. This solution produced profits 40% greater than the standard price action only model. In the area of financial reinforcement learning, there's always more opportunities to explore. Some topics of future consideration include the impact on trading on different currency pairs. So as I mentioned earlier, different currency pairs behave very, very differently, where something like a JPY currency pair might have much more dramatic up and down movements. Something like Euro USD is much more stable. I'd be interested in seeing how our model, when applied to a different currency pair, behaves. Another area would be the benefit of an alternative reinforcement learning method. As I mentioned, our reinforcement learning method was fairly simple. Deep-Q learning is about as basic as it gets. There's much more intelligent systems that would potentially produce a more intelligent process for our model learning. And I would be interested in playing around with some of those and seeing how it impacts the process. Another area would be the effect of different neural network structures. Here we only used a 3-layer deep neural network. It was very shallow. I would be interested in seeing how a more complex system potentially impacted the decision-making process. Another area would be exploring the success of reinforcement learning on a live market. At the end of the day, while this is certainly fun, it's always interesting to actually be able to apply this to live market and see how it behaves and whether or not what you studied within our closed little box of data science actually applies to the real world. So I'd be definitely interested in applying this to perhaps paper trading at start and then perhaps a live market later on with actual currency. Another area would be the impact of providing price feed observations as candlestick images. This had been something I had explored way back in the very, very beginning of my process. I was thinking about feeding in images of the candlestick charts into my reinforcement learning process and having it learn off of that. I'm just interested to see whether or not the visual aspect of it would help or hinder, opposed to giving just the price movement over each observation. And the final area of exploration that I'd be interested in would maybe be mitigating the loss by implementing a stop loss value. In the real world, you would never, ever, ever trade without having a stop loss implemented. We did not have one here, but given that we were only trading over 1 hour time steps, it would have been really easy to acknowledge where there was an issue theoretically. But I would be interested to see, by applying a stop loss in my environment, if it changed how the trading process occurs, especially if there's longer time periods between trades. And that's all I've got for you guys. Thank you for listening to my chat on programming for profit. I really enjoyed this process and getting to really dig into a specific area that I was interested in. Hope you guys really enjoyed doing your capstone thesis projects as well. I'm looking forward to looking at the rest of your videos. Have a great rest of your day. Bye.